Ryan Zupon, and our goal for this semester was to create a gas cleanup line. Now, why would we want to create a gas cleanup line? Well, for example, the Johnson County wastewater treatment plant, they have all this dirty gas that comes off of the wastewater and the trash, and all this dirty gas had to go somewhere because they couldn't just let it into the environment, and so they flared it, which means they take all this gas and they burn it. So it's not combustible, or it can't catch on fire in the air anymore once they flare it, but they're still harmful and they're still committing to greenhouse gases. So the EPA came in with some regulations that said you have to lower the amount you flare each day in order to help fight climate change and all that. And so what somebody already did for the Johnson County wastewater treatment plant was create a gas cleanup line. And what that is that takes all this dirty gas that they used to be flaring, and we're going to clean it up, keep what we need in there, and then make power out of it with an engine in the end.
What we're going to talk about is why we need the gas cleanup line, what parts are needed in the gas cleanup line, and how effective will the gas cleanup line be. For our gas, we have different types of molecules in our gas. First, we have methane, which is going to create our electricity. Next is CO2, but we don't need to remove CO2 out of our engine or out of our gas because it won't harm our engine. But the thing that we need to remove is water and H2S, and lastly, siloxane. Those are our three main things that we need to remove because they'll be harmful to our engine. We have 5 parts in our gas cleanup line. It first starts out with an H2S removal system, a blower, a heat exchanger, a siloxane removal system, and a CAT engine, and those will all be explained here briefly.
The first part in our gas cleanup line that'll take all this dirty gas and start removing the impurities, like Adam talked about, will be the hydrogen sulfide removal, which is H2S. And if we keep that in there, it's going to damage all of our machines and damage our engine. So we need to remove it. How we're going to remove it is include this in our gas cleanup line as the first part. So this dirty gas comes up out of the landfill, and we're going to go ahead and shoot that through this removal system. How it works is inside the removal system there's iron and the sulfite. Through a chemical equation, the sulfite is attracted to the iron scrubber with their intermolecular forces. The strength of attraction between the sulfur and the iron is much greater than between the sulfur and whatever is in the dirty gas. And so that sulfur, the hydrogen sulfide, is going to go ahead and latch onto that iron. And we're going to take that iron and that sulfur out of the gas. Now, this process also, this chemical equation also has a side effect, which is it adds even more water vapor to the gas. So next, Adam's going to talk about what we're going to do with this gas, and after that, I'll talk about how we remove this dangerous water.
Next, what we do with the gas is that we run it through a blower, which is basically a massive fan that just pushes our gas through the gas cleanup line. And why it's after the H2S removal system is because we don't need a bunch of pressure in the.
Well, this blower now has pressurized this gas to give it enough velocity and movement to go ahead and push it through the rest of our system. So that's why we need it there. Next thing, that after the H2S removal system and the push fan, the blower, we're going to have to get that water vapor out. And how we do that is through a set of 2 heat exchangers. So the warm wet gas has come out of the landfill, but we don't need it to be wet anymore because that'll damage the engine. So we got to make it dry. And how we do that is we have a chiller that continuously generates cold water. And so the cold water runs through pipes throughout the first heat exchanger. While the cold water is running through pipes, the warm wet gas is running across the pipes throughout the heat exchanger. And during that process, the warm wet gas, part of the water condensates onto the cold pipe that has the cold water running through it. And that's how we get this warm wet gas to become dry, colder gas. But that's just our first heat exchanger. Onto the second heat exchanger. In order for the temperature to not drop anymore, we don't want the temperature to drop anymore because then eventually more water will keep on condensating out due to the lower dew point. We need to raise that dew point. We need to make sure that the water isn't going to condensate to the rest of the siloxane removal system and then onto the engine. So we heat it back up, and we'll talk about where that heat comes from. It's going to come from the engine. So we'll talk about that. So we had the warm wet gas go through the first heat exchanger, become dry cold, and then we had it go through the second heat exchanger and become hot dry gas.
Next, we run it through the gas through the siloxane removal system, and we need warm dry gas to run through it because it makes it easier to remove the siloxane out of the gas. But siloxane is a gas that is emitted off of beauty products, and this product is extremely harmful to engines, even if you have a very small amount in your gas. And it needs to be cleaned up because it can damage your engine. Next we'll talk about our CAT engine.
So our CAT engine, a G3 516 CAT engine is needed. We chose that because it has low emissions. It's going to be the end of the gas stream, and it's designed specifically to take this now clean gas and make power out of it. And it's a combustion engine, it's an internal combustion engine. So that takes all the methane that Adam talked about earlier as the main power source, and it just like inside a car, we put that through the internal combustion engine and it generates electricity. So the whole point, once again, of this gas system was to make our CAT engine last longer and to make sure we don't have to flare off this gas. So there's a dual benefit purpose to this whole system. We need to have 2 CAT engines instead of 1. And why we need to do that is because at the Johnson County Wastewater Treatment Facility, they had to. So what they did is they would run one engine while the other engine would be resting or in repair, just in case one engine broke down for some reason. The other engine could take the extra load. So if we were to present this to the client, we would have to, as an engineer, we'd have to present this whole idea to our client and have him consult the construction engineer to get this going, and we just gave him the parts that he needs to buy. And so we're going to try to convince him to use our services with a pay me now or pay me later type influence, because he would want to pay now to invest in this whole gas cleanup line to clean his gas so he doesn't have to pay later to get a whole new engine and continually repair it because we didn't remove all those impurities. And so it's a cost analysis. And like I said before, the second part of this is to make sure he helps, or the client, he or she helps meet the EPA regulations.
This is Ryan Zupon with SIGA.
For you.
Okay.
It's not going to take long. Just our plans comply with new regulations
Okay.
and make them more efficient.
New regulations and efficient. Okay. There are many regulations that the utility world has to take care of and make sure they comply with. And SIGA is a consulting engineering firm that can help our clients achieve compliance. Related to compliance is also efficiency. So SIGA is also capable of consulting and providing solutions that increase the efficiency of the power plants, which allows them to produce the same amount of power while burning less fuel.
Next question we would like to ask is, how would an engineering firm like SIGA
take this logistical diagram we just went through and take the next step and put it into a business phase and make it happen.
So after conceptual design usually comes detailed design. So detailed design would identify particular interface points where one piece of equipment comes in line with the next one. And as an engineer, you've got to look at all the details about what nuts and bolts, what flanges, all the minute details that you develop an experience level with as you progress through your career. The next step following detailed design is often writing a specification. And what a specification is it's pretty similar to a shopping list for your recipe. You'd go to the store and buy the ingredients you need in order to make the whole thing come together. So the next key activity following the development of the P&ID that you described a second ago would be to begin the process of buying the equipment, ultimately to install and commission the project.
And last question what would be a few key points of advice that you would give an aspiring engineer to get off to a good foot after high school, onto college, and onto the job search? Also, what are some of the most important skills the engineer would need to have besides the technical knowledge they learn in school?
Well, that right there is a question that you could write a book about, but I'll try to distill it down to the best of my ability. So the fundamental foundation of every engineer is his technical competence. He needs to be able to speak with authority and knowledge about the things which he's responsible for. There's also a component of safety that comes with engineering, that the engineering that designs something is also responsible for all the aspects of it and the safe use of the product. So those are the two things that are of primary importance, and they can't be ignored. Having said that, the ability to communicate your ideas to people is extremely important in engineering so they can understand why the design criteria are what they are and why they matter so much. So I highly recommend anything that develops communication skills and professionalism and just how you present your ideas in a clear and concise manner.
Thank you.
Thank you, Ryan.